In this presentation, we're going to look at two examples of integration by parts questions. So this is the first of our two questions, definite integral, limits 0 and pi over 4, and the function is x times sine of 2x, okay? Now, so let's write this down, the general form of an integral for integration by parts. The answer is in the form, this is just separate to that statement there, uv minus the integral of v du. So what we have to do here is identify u, and in this case we're going to let u equal to x, that's u there. And we are going to have to identify dv, okay, that's dv there. Sorry, actually just as sort of a remark, actually the integral is, when it's in that form, it's the integral of u dv, and the solution is uv minus the integral of v du. So we have u and we have dv. So du dx is equal to 1 because x is equal to u is equal to x. Okay, that helps. So du is equal to dx in this example. Now this is the next part. We have to compute v, and that is the integral of dv, okay? And in this case, that is the integral of sine 2x dx, okay? So what we have to do is integrate that. Just as a remark, the integral of sine of ax dx is equal to minus cos ax over a. That's just a general trigonometric integration identity. Okay, so the integral of sine of 2x dx is equal to minus cos 2x over 2. Okay, just a remark, the coefficient we can just add at the end of the problem, and in this case it's actually a definite integral, so we don't even have to do that. So v is minus cos 2x over 2. Okay, so we have u, v, and du. Okay, so let's just recap. U was equal to x, du was equal to dx, and v was equal to minus cos 2x all over 2. Okay, so the answer is in this form here. The integral is u times v minus the integral of v du. Okay, let's write that down. That is equal to minus x cos 2x over 2. That's u times v, minus cos 2x over 2 dx. Okay, what I'm going to do here is first off note that we have a double negative. We have a minus here and a minus here. Those two minuses there. So what we're going to do is just replace them with a plus sign outside. Oops, got rid of the integration symbol there. So let's just rewrite that now. And also this 1/2 there, we can take that out of the equation as well. We'll just put it in front, use the factor rule. Okay, so we can set up our problem here like this. Now, cos 2x, what is that? Something very similar here. I'll just rub this out and start again. Cos 2x, or the rule is cos of ax is equal to sine ax over a. Okay, so that's the rule we're going to use for the second instance there, the second integration. Cos of ax dx is equal to plus sine ax over a. So that is equal to minus x cos 2x over 2 plus 1/2 times sine 2x over 2 Just double check that with my notes. Yeah, that's okay. Okay, so that's our integral sorted out. We could actually we have a half here and a half here, so we just put a quarter there. Okay. So all we have to do now is evaluate this for pi over 2, pi over 4, and 0. So let's just go here, just write it out again. So minus x over 2 cos 2x plus sine 2x over 4 pi over 2, pi over 4, and 0. Okay, so let's just evaluate for pi over 4. That is minus pi over 4 divided by 2. That's minus pi over 8. Okay, cos of 2x, or cos of pi over 2, plus sine of pi over 2 divided by 4 minus 0 over 2 cos of 0, okay, plus sine 2 times 0 over 4. The whole second term cancels out. That's 0 and that's also 0. The reason that's 0 is because we're multiplying by 0 here, and sine of 0 is also 0. So this whole second side becomes 0. Okay, so we just have to work with this bit. Minus pi over 8 times cos of pi over 2. That also works out to be 0. So sine of pi over 2, that term there just evaluates to 1. So the answer simply is 1/4. Okay, so that's the answer to the first one. I'm going to pause now and do a second one. There we have it there. The integral from 0 to 1 of x times e to the 3x dx. And again, the integral is in the form the integral is in the form, I'll write it here in black. The integral is in the form, it's not black, is in that form there, and the solution is uv minus the integral of v du. So here we're going to let u equal to x, that's going to be u there, and necessarily this part here is going to equal dv. So let's go back to, there we are. So u is equal to x, du dx is equal to 1, therefore du is equal to dx. Okay, so we have u and we have du. Now what we have to do is evaluate v. So v is evaluated by integrating dv. So in this case, that is the integral of e to the 3x dx. Okay. Now, a little bit of revision here. The integral of e to the power of ax dx is e to the power of ax all over a. So in this case, e to the power of 3x dx is equal to e to the power of 3x over 3. Okay, so v is equal to e to the 3x over 3. Now let's put this all together. So the integral uv minus the integral of v du, that is equal to x, which is u, times v, which is 1/3 e to the 3x, minus the integral of 1/3 e to the 3x dx. Okay, just to be clear, that part there is du, that part there is v, and v again, that part there is u. Okay, so we can simplify that just by saying x over 3 e to the 3x, just tidy it up, minus 1/3 e to the 3x dx. Okay. Now this one part we've done already. We actually just used the solution, the same solution that we've done previously. Just use that again. Okay. So that is equal to, I'm just going to make some space here on the page. There we have it again. So that is equal to pi over 3 e to the 3x minus 1 over 1/3. That is e to the 3x over 3. Okay. So yeah, that's the indefinite integral, pi over 3 e to the 3x minus 1 over 9 e to the 3x. Or as we could write it, as follows: e to the 3x by x over 3 is 3x over 9. Like that. We can write it like that. 3x minus 1 over 9. Okay. Now, what we have to do is evaluate this for the limits 1 and 0. So, e to the 3x by 3x minus 1 over 9. Evaluate that for 0 and 1. So, in the first case, we have e to the power of 3 by 2 over 9. So 3 minus 1 is 2. 2 over 9. And that's when you evaluate it for 1. And we have minus e to the 3x minus 1 over 9. Actually, I'll put the square there. The square bracket there. Minus 1 over 9. So that's 3 times 0 minus 1 is minus 1 over 9. The minus and the minuses cancel out. So we have e to the 3 by 2 over 9 plus e to the 3 times 1 over 9. So that should be a 1. E to the 0 there. I forgot that step. So e to the power of 0. Anything to the power of 0. 3 to the power of 0 is just 0. And e to the power of 0 is just 1. So we have 1 times 1 over 9. So we actually could just disregard that altogether. So on this side, we have just simply 1/9. When we evaluate it for 0, we just have 1/9. So, yeah, the answer is simply 2 times e to the 3 plus 1 over 9. That's the answer. Alright, that's that one. So that's 2 integration by parts questions done.